Well, good evening, everyone, and welcome here to the launch pad and our live launch coverage of SpaceX's Spainsat New Generation 2 launch, set to launch from Slick 40 at Cape Canaveral Space Force Station in Florida in just over 18 minutes. If it's your first time here, welcome. My name's Zach. I'm the founder and host here at the launch pad, and here at TLP, it's our mission to inform and inspire the explorers of tomorrow because we believe that space is better together. We're glad to have you joining us live here tonight. Weather looking great, 95% go for launch. We're watching those wind conditions as you just saw on your screen. We are awaiting SpaceX to begin their live coverage of today's mission, and once they do so, we'll be able to patch them in. We went live a little bit earlier than we were planning originally, and then we just had that little bit of a glitch there. Apologies for that. Unfortunately, SpaceX's website is down right now, so we don't have an exact time on when they'll begin their broadcast, whether it's the 20-minute mark, 30-minute mark, 10-minute mark. So we are eagerly awaiting them to begin their live coverage. Tonight's Falcon 9 booster is 1076, going for its 22nd and final flight. That's right, tonight's launch is an expendable Falcon 9. This booster flew for the very first time on November 26th of 2022, launching CRS-26 to the International Space Station from Florida. It then went on to launch OneWeb 16, Starlink Group 6-1, Intelsat 4E, and Tempo, Starlink 6-3. It continued on to launch Starlink 6-6, 6-14, 6-21, O3B mPOWER 5 and 6, Ovzon 3, Starlink 6-40, Eutelsat 36D, Starlink 6-54 to 6-64, Turksat 6A, World Legion 3 and 4, Starlink 8-19, 6-68, Sirius XM 9, Starlink 12-7, 12-14, and ends tonight with Spainsat New Generation 2. That's the one and only payload on board tonight. Looks like SpaceX is getting spooled up, ready for today's broadcast, so we're going to patch them in. Listen in to Mission Control for an update and countdown for the final 16 minutes and counting till launch. If you haven't yet, take a moment, engage the like button, share out the stream, and invite people to join us as we count down to the launch here tonight. Everything still continuing to look nominal, fueling well underway. At the T-minus 7-minute mark, that's when Falcon 9 will begin its engine chill.
You are looking at a live view of Falcon 9. We are currently awaiting liftoff at 9:30 p.m. Eastern Time from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida.
Spacecraft is on internal power.
I'm Tucker Spencer Wallace, a mission integration engineer here at SpaceX in Hawthorne, California. Today we are launching the Spainsat NG-2 satellite to a geostationary transfer orbit on behalf of our customer, Easdesat. Easdesat is a government satellite operator and service provider operating secure communication satellites, synthetic aperture Earth observation satellites, and maritime monitoring. Easdesat has provided Earth observation services with radar technology through the PATH satellite, which SpaceX launched on a Falcon 9 back in 2018. Spainsat NG is a program developed by Easdesat to improve the secure satellite communications and defense capabilities of the Spanish government, its allies, and international organizations including the European Union's GovSatcom and NATO. Spainsat will cover an extensive area that ranges from the United States and South America to the Middle East, Africa, Europe, and Singapore. The first of the satellites, Spainsat NG-1, was launched on a Falcon 9 in January of this year and placed into geostationary position at 29 degrees east. This launch will place Spainsat NG-2 into geostationary position at 30 degrees west. Due to the additional performance required to deliver this payload to orbit, this will be the 22nd and final flight for the Falcon 9 first stage booster supporting this mission. At T-minus 12 minutes, we are looking good for an on-time liftoff. If, for any reason, we are unable to launch today, a backup opportunity is available tomorrow with a 4-hour launch window opening at 9:30 p.m. Eastern Time. The vehicle is currently healthy, the range is ready to support, weather is go for launch, so let's take a moment to meet our SpaceX Falcon 9 rocket. The two-stage Falcon 9 vehicle with the payload fairing is 70 meters or 229 feet tall. When fully loaded, it will hold just over 1 million pounds of propellant, which the vehicle will burn through in less than 3 minutes after liftoff. At launch, Falcon 9 produces more than 1.7 million pounds of thrust, and rockets like Falcon 9 don't use all that power just to go straight up. Early in flight, Falcon 9 will perform a gravity turn, a smooth pitch maneuver that tilts the rocket sideways to build up horizontal velocity. You may hear this call out about 10 seconds into launch as vehicle pitching downrange. Once the first stage completes its portion of the mission, it will shut down and separate. A staged rocket like Falcon 9 sheds the booster so that Stage 2 and the payload can keep climbing faster and more efficiently. At the bottom of the first stage are 9 Merlin engines that propel Falcon 9 off the ground and up to the thinner parts of Earth's atmosphere. The first stage is designed to be reflown with minimal refurbishment between flights. As mentioned at the top of the show, due to the additional performance required to deliver today's payload to orbit, this will be the 22nd and final flight for the first stage booster supporting this mission. This booster first launched on November 26, 2022, and has since then logged 1,062 days in service. Over the course of its career, it has launched 3 times from Space Launch Complex 39A at Kennedy Space Center, and today will be its 19th launch from Space Launch Complex 40 at Cape Canaveral Space Force Station. It has returned from orbit to Earth 21 times, landing on a drone ship in the ocean 18 times, and on land 3 times. So today, we will say farewell to a booster that has served us and our customers well, having launched NASA's CRS-26 cargo resupply mission, OneWeb Launch 16, Intelsat IS-40E, SES-03B mPower-C, Ovzon 3, Eutelsat 26D, Turksat 6A, Maxar 2, SXM-9, and 12 Starlink missions. Our payload today, Spainsat NG-2, is safely enclosed inside of the 17-foot diameter payload fairing, which is the structure at the very top of the rocket. Made of a carbon composite material, the 2 sides of the fairing form a clamshell around the satellite to protect it during ascent. The fairing halves are then separated at about 3.5 minutes into flight, after which they will parachute back to Earth. If recovery goes to plan, the fairings will be pulled from the ocean and prepped to fly again. The fairing halves supporting today's mission are flight-proven, with one half flying for its 28th time and the other flying for its 16th time. Below the fairing, we have the second stage, which is the part of the rocket that will take the payload to space today. The second stage will ignite its single Merlin vacuum engine, or MVAC for short, about 2 minutes and 48 seconds into flight, and will then relight for a second time before we deploy the satellite. With its extended nozzle and optimized design, the MVAC drives maximum performance in the vacuum of space. While the countdown continues, let's find out more about the satellite that we're delivering to orbit today. Next up in the countdown, the transporter erector, or TE, will begin to retract away from Falcon 9. That is the large trussed structure you see standing next to the rocket. It is hinged at the base and connected to the launch mount beneath the first stage. First, we'll see the clamp arms open around the second stage.
Tank suppressing for strong back retract.
And that's a good indication that we are on track for an on-time liftoff as the transporter erector prepares to retract. Like I said, first we'll see the clamp arms open around the second stage, and then the TE will begin to pivot back, slowly swinging away from the rocket. It'll reach full recline by T-minus 3 minutes and 40 seconds. You may also hear the TE called the strongback. The same structure.
Strongback retract has started.
Different name. And as you heard there, strongback retract has begun, so watch for those arms to start to open. The TE does roll the Falcon 9 out to the pad. It also raises it vertical and stays connected through the final seconds to launch. It provides fuel, power, telemetry, and command connections between ground systems and the rocket. We're just about to see those clamp arms start to open around the second stage of the vehicle. Those clamps help to stabilize the second stage during propellant loading, and are also there to prevent movement in high winds. Once they're open, the rocket will be fully free at the top. And there you can see on your screen, those clamp arms have fully opened. The launch tower's strongback is now beginning to move away from Falcon 9, allowing it to stand freely before liftoff. The TE has two components, a strongback alongside Falcon 9 and a launch mount underneath. The launch mount has 4 hold downs that release at T0. The strongback is hinged to that launch mount and is rotating about 2 degrees away from Falcon 9. At liftoff, the strongback will move 45 degrees away to clear the way for Falcon 9's launch. At this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. The first stage and second stage should finish loading liquid oxygen.
Stage 1 LOX load is complete.
And there you just heard, the first stage has finished LOX loading. Liquid oxygen loading for the first stage is the final propellant load for the booster. The tanks are also pressurized using helium, which is chilled so that it stays compatible with the cryogenic plumbing. During flight, that pressurization helps force propellant into the engines as the tanks empty. At T-minus 60 seconds, Falcon 9 will enter startup. At that point, the rocket's onboard flight computers will take over, and from there on out, the countdown will be fully autonomous. Just inside of T-minus 2 seconds, the 9 Merlin 1D engines will ignite, and once they're at full power, Falcon 9 will lift off the pad and begin its climb to orbit. After that engine start, the Falcon vehicles are held down until all vehicle systems are verified as functioning normally before we release for liftoff.
Stage 2 LOX load is complete.
And liquid oxygen for the second stage is now fully loaded, completing prop load for the upper stage. You can see white condensation clouds starting to vent from the rocket. As the liquid oxygen warms slightly inside the tanks, some of it will boil off, and that gas is vented to manage pressure. When the vented oxygen hits the warm, humid outside air, it will instantly condense into clouds, which is the same principle as your breath on a cold morning.
Ground gas closeouts.
Standing by now for confirmation that Falcon 9 is in startup at the T-minus 1 minute mark.
Falcon 9 is in startup.
As you just heard, the autonomous flight computers have taken over the launch countdown, and stages 1 and 2 are pressurizing for launch.
Go for launch.
We just heard the launch give the final go. With that, let's listen in to the countdown.
T-minus 30 seconds. T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Go Falcon, go Spainsat NG2.
Vehicle is pitching downrange.
M1D chamber pressure is nominal.
As you can see, Falcon 9 has lifted off from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. The Falcon flight computer will now begin throttling down engines in preparation for max Q, or maximum aerodynamic pressure.
Power and telemetry nominal.
Good call out there for a nominal state of the vehicle.
Vehicle is supersonic. Max Q.
As you just heard, we've just passed through max Q. Again, that is the maximum aerodynamic pressure the vehicle will experience. In order to achieve orbit and avoid being pulled back to Earth, the Falcon 9 rocket needs to reach a velocity of roughly 17,500 miles per hour horizontally. To assist with this, the first stage performs a gravity turn, initiated by a pitch-over maneuver just 10 seconds into flight. This is also the engines gimbal a small amount for about 5 seconds, slowly turning the first stage into an angled trajectory. This angled trajectory combined with gravity's pull will place the rocket into the final horizontal flight path. You can track our progress to orbit by keeping an eye on the first and second stage telemetry in the bottom corners of your display. Now we are going to have several events coming up in quick succession, starting with main engine cutoff, or MECO, when we shut down the 9 Merlin 1D engines on the first stage. Following that, the first and second stages will separate. Following that, we'll have the first ignition of the MVAC engine, also known as SES-1. SES-1 will shortly be followed by fairing separation.
Stage separation confirmed.
Main engine cutoff. MVAC startup.
And there you heard and saw those events that happened back to back: MECO, stage sep, and SES-1. As a reminder, the first stage will not be recovered today. In preparation for this, we removed the landing legs and grid fins to decrease the mass of the first stage and save them for use on future missions. But for now, we say to the first stage, thank you and farewell. Fairing separation is next in just a few seconds. We will be attempting to retrieve both fairing halves once they fall back to Earth using our recovery vessel, Doug.
Fairing separation confirmed.
And as you just heard, fairing separation has been confirmed. These fairings will orient themselves with gas thrusters for entry into the atmosphere. As they near the ocean, each fairing half will use a gas-powered deployer to release a parachute. The fairing computer will send commands that steer the fairing to the ocean landing, where Doug will attempt to recover them. With that confirmation, we have a few minutes between our next major milestone event, SECO-1, when we'll shut down our MVAC engine on the second stage. We're going to take a short break, and we'll be back in about T+7 minutes. of the Spainsat NG-2 mission. Liftoff occurred at 9:30 p.m. Eastern Time from Space
Stage
Launch
2
Complex
terminal guidance.
from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. And we've had a nominal flight so far. As we mentioned before the break, coming up next, we'll shut down our MVAC engine on the second stage, also referred to as SECO 1, which should occur at about T plus 8 minutes. After that, we're going to look for confirmation of good orbital insertion. The MVAC engine is optimized to operate in space, producing...
Stage 2 FTS has safed.
There you just heard that our Stage 2 FTS has safed. As I was saying, the MVAC engine is optimized to operate in space, producing 220,550 pounds of thrust in vacuum, and is designed to be stopped and restarted multiple times.
MVAC shutdown.
And there you heard the call out for second engine cutoff, or SECO 2, as MVAC shutdown. We're now awaiting confirmation of nominal orbital insertion.
Nominal orbit insertion.
And we have confirmation of nominal orbital insertion. The second stage is now embarking on its coast phase. After the coast phase, we will light that MVAC engine for a second time, just before the T plus 27 minute mark, and that will be followed by payload deploy around the T plus 34 minute mark. We'll see you back here at about T plus 25 minutes. with live coverage of the Spainsat NG mission. Recapping events so far, we had an on-time liftoff at 9:30 p.m. Eastern from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. We saw a successful main engine cutoff, stage separation, and the first light of our MVAC engine, or SES-1. That was followed by fairing separation. Those fairing halves are currently being recovered by a recovery ship, Doug. This was the 28th flight for one fairing half and the 16th flight for the other. We also heard the call out for second engine cutoff, or SECO-1, and confirmed nominal orbital insertion. We are now moments away from lighting the MVAC engine for a second time to propel the stack into geostationary transfer orbit. Now let's wait for those callouts. We'll be expecting this callout coming in just about 30 seconds.
MVAC startup.
And as you just heard, our Merlin engineering team has confirmed that we have power on the second stage engine. This burn will last approximately 67 seconds, typical for a geostationary transfer mission. If you watch the speed gauge on your screen, you'll see us adding over 2,500 meters per second to the velocity of the second stage and the Spainsat NG payload. Maximum acceleration during this burn will reach 4.8 Gs as the remaining propellant is burned off. Stay tuned for second engine cutoff, or SECO-2.
MVAC shutdown.
And with that second engine cutoff, or SECO-2, we're just a few minutes away from payload deploy. We're going to take one more short break until that event, and we'll see you back here in just about 2 minutes. satellite communications and defense. As we come up shortly. If you're just joining us now, we are currently awaiting the payload deploy of the Spainsat NG satellite into geostationary transfer orbit. And we're just now expecting payload deploy in about 1 minute.
Payload deploy confirmed.
And there you just heard the call out, and you can see the successful deployment of the Spainsat NG satellite as it begins its journey to its destination geostationary orbit. And with that, we're going to wrap up our coverage for today.